Hi everyone, today we're going to talk about special cases and factoring greatest common factors. So the special cases is going to start with continuing our multiplying that we were doing last class. And then we're going to start into our factoring part of this unit. So let's talk first about the square of a binomial. So remember, a binomial is something with two terms in it. So if we square a binomial, what happens? You can always use your favorite method. Remember, we talked about the double distribution, the box method, or the FOIL method. You absolutely can use one of those three methods, but sometimes it's just a quicker way to do it. And if you get the pattern, you can always follow that pattern instead of having to go through and do all the work with the other methods. All right, so the square of a binomial means that we take a binomial and we multiply it by itself. So for example, if I have a plus b squared, so this is just generic, we're talking just a general rule here. All right, so when I square that, it just means I'm doing the same thing, repeating it, a plus b times a plus b. So what I'm going to show you next is the pattern that we would always follow when I'm squaring a binomial that's being with addition. So the pattern is always going to look like this. It's the a term squared plus 2 times a times b. So 2 times the product of a and b plus that b term squared. This is just the pattern that it would follow every single time. And as we go through down below and we look at those, we'll look at that pattern. Now, when this sign in the middle is subtraction, the pattern looks slightly different. So again, it would then be a minus b times a minus b. So our pattern for this one, whoops, I did not mean for that to pop in. Our pattern for this is going to be, again, square the a term. This time we put subtraction in, and then we do 2 times a times b, and then we square the b term. So the only difference between these two with the patterns is this first sign. That's it. All right, now the product of a sum and difference of a binomial. Right? So what does this mean? It's a binomial with addition times a binomial with subtraction. So a binomial with addition times a binomial with subtraction. Right? In this case, our middle term will always cancel. So an example of that looks like this. So here I've got a plus b times a minus b. The first terms are the same. The second terms are the same. The only thing that's different is I've got a plus sign and a minus sign. Right? So it would end up looking like this. My middle term, that AB term in the middle, cancels out, and all we're left with is squaring the A term, squaring the B term, and putting a subtraction sign between them. So, like I said, you can absolutely go back and use any of those three methods that we learned last class. Okay? You can use double distribution, you can use the box method, you can use FOIL, whichever one you like. But these are nice little shortcuts to help us remember. These are also really nice because when we do get more involved in factoring, if you can recognize these patterns, then it makes it a lot easier to factor them. Instead of having to go through all the work, we can follow the patterns and get to our answer a lot faster. All right, so example 1, simplify. So here we have a square of a binomial. So we're going to follow that pattern. Remember, our pattern is a squared plus 2 times a times b plus b squared. The first term is your a, the second term is your b. So let's fill in everything. My a term was that 3n, my a term, 3n, my b term is the 2, my b term is the 2. Okay, so a, b. All right, now I can just simplify. All right, so 3n squared. When we do this, that means I'm doing 3n times 3n. That gives me 9n squared. 2 times 3n times 2 gives me 12n, and then 2 squared gives me 4. So by following this pattern, I don't have to do all that other work that we did in the box or foiling or double distribution. It just cuts down on the amount of work that you have to do. All right. So this is what would have happened if we had done that distributive property. If I did that 3n, if I did FOIL, 3n times 3n was 9n squared. 3n times 2 was 6n. 2 times 3n was 6n. 2 times 2 was 4. So I can absolutely do that FOIL or box or anything like that to get to this point, combine those middle terms, and we still end up here. All right, let's take a look at this one. Again, I'm going to use that pattern. So in this case, my A is the 2g, my B is that 1. So when I go to substitute them in, it'll look like this. But just remember that when we have that subtraction sign, we follow that subtraction sign as our first sign. The second one's the addition sign. All right, now we can go through, work through each part. So we get 2g squared gives us 4g squared. 2 times 2g times 1 gives us 4g, and then 1 squared is 1. All right, well, we can also just use our regular FOIL, okay? So I can do that 2g times 2g gives me 4g squared. 2g times negative 1 is negative 2g. Negative 1 times 2g is negative 2g. And then negative 1 times negative 1 is a positive 1. I can combine those together to give us that middle term. So again, in the end, it does not matter what method you use. The whole purpose of this is just to give you another strategy, or not even a strategy, a simpler way to do certain problems if you choose to use this method. All right, you will have some try on your own, so I'll have you come back to those at the end. All right, now, this next problem here is following along with the product of sum and difference of a binomial. Okay, so product means we're multiplying the sum and the difference of binomial. We're going to notice that that A term and that B term are the same. The only difference between these two binomials is that sign in the middle. All right, so if we were to follow the regular way of doing things, we would distribute that 5r if we did FOIL, or if you did the box, this is what we'd end up with. 5r times 5r gives us 5r squared. 5r times negative 1, oh, this one actually went backwards. This one did the 1 times 5r gave us positive 5r. Then the 5r times the negative 1 gives us the negative 5r, and then the 1 times negative 1 gives us negative 1. Okay. Now, if we were to use our pattern, okay, remember that a plus b and a minus b works into this pattern here. We square, okay, what's going to happen? I put in my a term, which is the 5r, I put in my b term. All right, well, I'm going to come back to this one now. What happens when I combine my middle terms? A positive 5r minus 5r. Right? Well, they cancel out and they make 0. Same thing's going to happen here. I square this, we have that minus sign in the middle. Two different strategies to get the same answer. In the end, it does not matter which strategy you use, as long as you are showing some work to get to that final answer. All right, so we have another try on your own to practice working with that pattern, okay, if you so choose to. All right, now let's go into our factoring. So this is the beginning part of factoring for us. So we're going to start with factoring out a greatest common factor. And when we come into class next time, I'm actually going to show you how you can utilize your calculator to help you with this as well. If you're not very good at your math facts or you've forgotten some of your math facts, I can teach you a way to use your graphing calculator to help you find those greatest common factors. So greatest common factor is the largest positive integer everything can be divided by. Okay, so it's the biggest number that can divide into all the numbers they're presenting you with. So the greatest common factor of 28 and 42. Well, the long way to do this is something that you learned quite a while ago. List out the factors of 28, list out all the factors of 42. So we've got 1 times 28, 2 times 14, 4 times 7. For 42, 1 times 42, 2 times 21, 3 times 14, 6 times 7. Now we need to look for what's the biggest one that both of them have in common. Well, when I look through, they both have 14. That is the biggest one that they have in common. So my greatest common factor is 14. All right, now when we're doing exponents, x to the third is the same thing as saying x times x times x. X to the seventh then is the same as saying x times x times x times x times x times x times x. All right, what we're really looking for then is what's the total number of x's that they have in common, or how many x's do they have in common? They have 3 x's in common. It basically comes down to what's your smallest one, because that's the most that they can have in common is 3. So our greatest common factor then would be x to the third power. Right? They each have x to the third power. All right, so now I want you to come down here. These are going to be your try on your owns. Right? And so the last thing I'm going to go over with you is how to factor out this polynomial. This is essentially doing the distributive property in reverse. Okay? Distributive property in reverse. So we need to first take a look at our two terms. What do we have? I have a 3x squared and I have a 9. So we need to figure out our factors first. What are the factors of 3? We're going to look at the numbers. And what are the factors of 9? So factors of 3 are 1 and 3. Factors of 9 are 1, 9, and 3. They both have 1 in common and they both have 3 in common. 3 is our greatest common factor. When we look at variables, the first term is the only one that has any x's. This does not have any x's, so there's no x's in common between the two. So here's what we're going to do. We're going to divide both of these terms by 3. So we take them, we divide them both by 3, and here's what that's going to look like. So I can have that 3x squared minus 9. And now what I'm going to do is divide them both by 3. So now I'm going to divide this one by 3, and I'm going to divide this by 3. We're undoing that distributive property. I'm pulling a 3 out. So 3x squared divided by 3, well, we can really only divide the coefficients. 3 divided by 3 is 1. 9 divided by 3 is 3. So we get this when we divide, right? Those 3's end up canceling each other out. So I'm left with just the x squared. 9 divided by 3 is 3. Well, in order to get to that 3x squared minus 9, I have to take this and multiply it back by 3. What I've really done is to undo that distributive property is take this 3 and I pulled it out of the 3x squared minus 9. To check, I can do that distributive property. So 3 times x squared is 3x squared. 3 times 3 is 9. So now it works, so now I know this is my properly factored answer. All right, let's take a look at this one here. We're going to start with our numbers to find our factors of 6, 18, and 16. Factors of 6, factors of 18, factors of 16. When we look, they all have 1 in common. That's always going to happen. 6 and 18 both have 6. They all have a 2. 6 and 18 also have a 3. So the biggest one that all 3 have in common was the 2. Okay, so that 2 is going to be our greatest common factor. So we're going to take each of these terms, divide them by 2. Right? But not just the 2. We also need to pay attention because every term has the x's. So x to the 4th, x to the 3rd, and x squared. Right? X to the 4th, x to the 3rd, x squared. What do they have all the same? Well, we have to go to the one with the smallest exponent because that's the maximum number we can include in that group. So x squared is what they all have in common. So my greatest common factor here for this one, it's not written out, but I'm going to type it in here. So my GCF for this is going to be 2x squared. Oops, wrong one. 2x squared is my greatest common factor for this one. So that means I have to divide each of these by 2x squared. When I do that, I divide my coefficients and subtract my exponents. That's going to be key. So divide the coefficients, subtract the exponents. So 6 divided by 2. Actually, I can't move that down, never mind. 6 divided by 2 is 3. X to the 4th divided by x squared, I would do 4 minus 2 is 2. 18 divided by 2 is 9. 3 minus 2 is 1. 16 divided by 2 is 8. 2 minus 2 is 0. So those x's would cancel out. Right? We would end up with this. That greatest common factor moves to the outside because we've pulled it out, and what's left after division is what goes inside. So that is our final answer. Think of setting it up like a division problem like I did here. Right? What you divide by is what comes out. The result after you divide is what stays inside. Again, I can take this and distribute it through, and I would end up with the same answer as this right here. All right, now you got these 2 more try on your own. So you have a total of 5 try on your own problems. Nope, you got a couple more than that. Just kidding. A few try on your own problems. Give those a try though, please, before you come into class, and we will get some more practice. And I'm going to touch base a little more with you guys at the start of class just to go over this process right here. All right, I will see you then.